So for number 2, I actually want to we're going to move into doing a statistic. Now, originally we were going to do some statistics on SPSS, but I think with the 4 weeks here, if you need extra SPSS help, I'll be happy to do that. But in this refresher course, I wanted to talk more about concepts. We'll look at some tables and some outcomes, but not going to necessarily show how to type things in and set up input files.
Has anybody over here actually gotten a copy of SPSS yet? Has this been like an act of Congress
Yeah.
to try to get these over here for our people to use in research?
I hear you.
So, I mean, I used it at my previous institution.
What
I'm
institution
not
was that?
BCU.
Oh, okay.
But I'm not up, I'm sure there have been several iterations since I
It's
used it, so.
technology around Mary Baldwin has been a bit of an issue.
It's just crazy to me how hard it has been to get people who want to do research a copy of SPSS to use. It's impossible. I still don't have one. I've been here for 5 years and I can't get one.
So it is a difficult proposition in some situations. I hear you, and I've heard that a lot from people around here.
Has anybody in here used SPSS at all?
When I was in grad school.
Yeah.
So if there's another
Like
semester,
zero ability, and it's because we can't get them over here for people to even practice on.
I hear you. So let's move on. That's not something I can actually. You'll have to bring up with.
We're continuing to work on it, but we
Yeah,
have
a
not
continuing
had
to be worked on issue. So I think I had the previous one, how many people like statistics or not, but today we're going to be talking a little bit about the concept of burnout. How many people are familiar with the concept of burnout? Okay, so just a simple yes/no question. How many people feel at this moment in time burned out? Please raise your hand. 1, 2, 3. That's why you guys are sitting over there, right, in the back.
We're all burned out.
So 3 are feeling burned out. Would it be true then the rest of the group is not?
We have moments.
Moments.
Yeah, it depends on what
Yeah,
burnout
yeah.
you're talking about.
So we will say, for the sake of example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why don't we do, just for a simple example here, say that 3 people in the class, if you want to write this for your notes, 3 people are burned out, and 7 people are, we'll say, NBO, not burned out. So, very simple situation there. We're getting frequency-based data. The type of statistic we use when we get... So, by the way, everybody at that table is looking at the rest of you saying, you're all burned out, why aren't you telling the truth?
Should put pizza in that question, not burnout. There. Program director's in the room. I mean, like pizza.
I actually thought that everybody was going to raise their hand on the burnout thing. But that's okay. So we'll say for the sake of
Better
it...
now.
What's that? Well, see, your comments about, I've been trying to get SPSS for years here, and I can't, is kind of a burnout-ish kind of statement there. But we'll go with kind of 3 say they're burned out, 7 said they're not burned out. That's what we'll go with. So the question is, what kind of statistic would be appropriate to do with that? We're getting frequency-based data. We have 2 categories, 3 in this category, 7 in that category. What's appropriate?
A percentage.
A percentage. So you could do a 3 out of 10. That's a descriptive statistic. That's not a bad answer. You could just get 3 out of 10. But in statistics, we like to say things are significant or non-significant if we possibly can. And so you could say 30%. Is that probably significant? Probably not. But we could say 30% are burned out. But the statistic we would choose, we have one variable, that's the category, and we're collecting frequencies. When we collect frequencies, we use something called a chi-square. A chi-square. You guys familiar with the chi-square gig? Sorry, I shouldn't say gig, but we're all friends, so we can do that. A chi-square. And in a chi-square, and I think I put the formula kind of up there. No, I didn't necessarily do that. Let me go up there. In a chi-square, whoa. The formula we use is FO minus FE quantity, and just give me an SQ for squared. And we do, I don't want to put a symbol in here, sum of FO minus FE squared divided by FE. So what's your obvious question when I say this to you? FO and FEs, what would you want to know?
Where's FO and FE?
What's FO and FE? Good thing I didn't put up, I'm from New Jersey, good thing I didn't put up FU. Okay, because we all know what that means from New Jersey. Sorry about that. So FO. FO actually stands for frequency observed. What are the two frequencies we observed with this class? Well, I'm sorry, with this group. Yeah, we can say class. What were the two frequencies that were observed here? So we had FO of 3, and we had an FO of 7. So the next question is FE, and FE is the frequency expected due to chance. FE is frequency expected due to chance. What number would you give me there? What number would you give me? The frequency expected, if our results were completely due to chance, what number would you give me for frequency expected due to chance? 5. Why did you say 5?
50-50.
Because we have two categories. We have 10 people, because I wanted it to be 10, because that's a nice simple number. So FE in this case is frequency expected due to chance, and it's 5. And so now we do a little bit of math. So FO minus FE squared over FE. So we kind of start out, what was the first frequency observed? 3 minus 5, quantity squared. Then you can do plus, what was the second category? Parentheses, 7 minus 5, quantity squared. And divide all of that by what? 5. So if you do the math on that, and it's the sum for the numerator, 3 minus 5 is what? 2 squared, it's 4. So you got 4 up there, and then 7 minus 5 squared is another 4. So what do we got there? 2, 4. We have a total of what for the numerator? 8. And what's the denominator? 5. So what's our final frequency observed? Got a little calculator there? 8 over 5 is what? 1 and 1.6. Did you guys get that? Yep. 1.6 equals kind of the chi obtained. What would you do with that? Does that sound like a good value to get? Are we optimistic about that value? Does a chi of 1.6 sound? The answer is no. What you would need to do is you would need to either do it on a computer, or you could look it up in a textbook and look up in a book what the critical value would be. And as it turns out to be significant, and I put it on the little outline here, if you have two categories, right? We have two categories. Your F critical, sorry, your, oops, lost my place there. Your chi critical score with 1 degree of freedom is, I looked it up in the textbook before I came over here, 3, kind of getting used to that, 3.84. So our chi value was 1.6. The critical value is 3.84. So how are we? Significant or non-significant? If your obtained value is less than your critical value, you are non-significant. We are non-significant here. So the way you would write this out, not too good at making chi's, sorry, it's an x squared. Have you seen the chi symbol before? We'll look at an article in a minute, but chi, and then it would be, we have 1 degree of freedom, and then n, what's our n equal here? 10, close parentheses, equals, what was our value? What did we get, the chi obtained? 1.6, comma, p what? Greater or less than 0.05? Greater than 0.05. Real world statement. What's the real world here? Is there a significant percentage of the group that is burned out or not burned out? No, there's no significant difference. In this sample, there is no difference in terms of burnout or not burned out. Does that make sense for a chi-square? Comments or questions about that? Don't worry, we won't be doing too many statistics by hand, but this is kind of a simple and fun one. Well, fun for stat people. So we kind of use it. Okay, so I'm going to stop the